Welcome back to the Monday Morning Haskell video blog. Last week we talked about the function monad, and this week we're going to talk about another more obscure monad that it's very present in a lot of the monadic operations we're doing, but you don't think about it that much. And this is actually going to be the identity monad. But to motivate what's happening in the identity monad, I'm actually going to start by talking about the maybe monad. So let's just think about how maybe looks as a functor. So if we just say instance functor for maybe, we have the fmap function, and when we fmap over nothing, we get nothing, and when we fmap over some just a value, we get we just apply that function f, and the applicative and monad instances for maybe are also just very similar to this as well. And maybe encapsulates the computational strategy where we might fail. That's what nothing is nothing represents an operation that has failed. But what if we were to take away this sort of failure option? What if we only had just this single constructor, and all it does is wrap a value, and when we apply functions across our type, we're just applying them to the wrapped value. This effectively is what the identity type is, and as we might note, doing this to the maybe function, we sort of take away the maybe computational strategy, and ultimately the identity monad then is going to be a monad that has no computational strategy. So we're going to start off by defining the identity type. So this is going to be new type identity. It's just a simple wrapper around another type, and we'll use the identity constructor. And for the field name, it's actually run identity. And the reason for this is that run identity allows us to convert our base sort of identity element, the wrapped type, the functor or the monad, and just convert it into the unwrapped value. And this is what run functions do in a lot of other monads like run state, run reader, etc. And so we're kind of doing the same thing. Now, let's imagine now what it is like for us to make a functor instance for identity. And it's going to be exactly like we have with this sort of, reduced maybe example. We're just going to wrap it with identity instead of with just. And that's what our functor instance looks like. If, we were to do the same thing with applicative, it's very simple. Pure is just equal to identity, is just equal to that wrapper constructor. And if we were to apply a function in an applicative fashion over the identity element, identity A, it's just going to be the same thing as the functor, basically. We're going to have it map the function f over the inside element. And if we were to make a monad instance for this identity type, and if we were to make a monad instance for this identity type, then return, again, is just going to be equal to identity, just wrap our value, and then the bind operator is going to be a little bit tricky. I actually have to think about this since we have f, or wait, I might have it backwards. It's not f, just go back, we have the identity element itself, bind that to a function f, and the result of that is just going to be f applied to the inside element. And again, remember that f, that function in the monad type class when we're applying with bind, it's going to rewrap our value in the identity monad. So this is all we'd have to do for these complete types. We get these for free. We don't have to actually define them ourselves. But what's the point of this identity monad? How do we actually use it? And the first sort of function it serves is that it is a base monad for a lot of other monads. So we see here we have just a very simple reader monadic action. So reads an int, produces another int. But if you know much about monads, you probably also know that there's reader t, and this is a monad transformer that allows us to wrap over a different monad. So you might have reader t int and then IO. But when we just have reader, it turns out that reader is actually a special case of reader T and not the other way around, because what reader really is reader T int and then the identity monad. So our sort of base monads, reader, writer, state, without the T, these are really just special cases of the transformation where the base monad is that identity monad. So you can see I've changed the type signature. Just gonna save this again, and we'll see, this compiles, nothing really happened there. And in fact, when we call run reader, we could, if we wanted to, use run reader T in conjunction with run identity. So suppose we have, the my reader action. We're just going to call run reader T on our action with, and apply that to the value 5. But remember, this doesn't produce the pure value. We want an int. This will actually produce the identity value. If we go ahead and run that, says it, it expects an int, but really we're producing an identity. But it's very simple to fix this. All we do is say run identity. It's our function application operator like we learned a couple weeks ago. And now everything is all fine. And we can, in fact, take this one step further. We can write our own run reader function that will take a reader action and the proper input and produce its output. And we'll define this function in terms of runner reader T and run identity. So this can be totally generic. So we'll need our action as a parameter. We'll say run identity, function composition, run reader T on action. And we should actually get that will work. So we'll call identity, it's a module.value, and we'll get that it's 10 because we're adding 5 to our input there. You might be wondering, okay, what really is sort of the use for this identity monad? And there obviously aren't that many uses for it because there's no computational strategy involved. But one thing to think about is supposing that we have this generic function. So looking here, we have this transform int function, and it operates on a monadic value. So we have some monad m. We don't really know what it is, and this could be the same if it were a functor or an applicative, but it happens to be a monad right here. If we try to use this function just with an unwrapped value, we're going to run into some problems. So if we were just to call transform int and on 5, it doesn't work. It's trying to turn 5 into a monadic value, but it doesn't actually know how to do that. So the way to do this is we just wrap our input in the identity monad. So we first we're going to have to import identity into the GHCI, and then we should be able to do transform int identity 5. And so now our function works. We're able to create the int as a double and then give triples values. So we get 5.0 and 15. If we wanted to, we could also call run identity on that, and we'll unwrap it again so it doesn't have to be in the identity monad. So we can actually leverage this transform int function to write a sort of pure version of the function. So we have transform int, we put an apostrophe there, and this will take an unwrapped int and produce an unwrapped tuple. And all we want to do here is wrap our input in identity, and then we can call transform int, use our function, and then unwrap it with run identity. And we just compose these together, and we should get then that we can call transform int, and we can just provide a pure input, get a pure output. Don't actually have to deal with the identity monad. We're just doing that in our function. Of course, depending on the situation, you might do the reverse. You might actually write the pure function first and leverage that in your monadic function, but it all just depends on circumstances. So that's all for this video on the identity monad. Don't forget that we have our new course, Making Sense of Monads. If you want to learn more about monads, perhaps you've been struggling with this topic as you're trying to get better with Haskell and you want a lot of examples to work with, you can find the link for that course in the video description below. If you subscribe to the Monday Morning Haskell mailing list, then you'll get a discount code, so you can get 20% off that course. So hope to see you in there.